Hello everyone. In last lecture I was discussing about residual stress measurement technique, especially destructive and semi-destructive residual stress measurement techniques, where the principle of stress relaxation technique was used. Today also I will discuss about rest of the different destructive and non-destructive residual stress measurement techniques in details. So, first of all, this is the content of today's lecture, that means measurement by stress relaxation techniques. So, what I have told you, the stress relaxation technique is a either destructive or semi-destructive types of measurement technique. So, last class I was discussing about sectioning technique by electrical strain gauge, so to measure the residual stresses. There I was discussed actually how actually measure the residual stress by using electrical strain gauge, and its basic principle also I discuss in details. Today I will discuss rest of the stress relaxation techniques. So, first of all I will discuss about Measurement-2 drilling technique. This is also a semi-destructive types of residual stress measurement techniques, when a small circular hole generally is drilled in a plate containing residual stress. The residual stress in the area around the hole is partially relaxed here. So, the residual stress that existed in the drill area generally is determined by measuring the stress relaxation. So, here also we use stress relaxation techniques. Here especially three different strain gauges are placed at a angle of 120 degree from each other, and then the hole is drilled in the center. So, in previous case you observe that the trepanning operation was done outside the strain gauge. That means the component which were removed from the specimen, that component was removed by trepanning techniques. So, in that specimen generally which we were removing from the specimen, that was generally containing the what it is called strain gauge. In previous stress relaxation techniques I have already discussed. So, there the hole was creating outside, that means around the strain gauge, but here the hole, or you can say drill hole, will be made in between the what it is called inside the strain gauge location. How it is, that also I will explain in detail. So, once we generally make a hole, drill hole, then there will be the stress relaxed. By the stress relaxation principle, we can record the strain release due to this drilling of hole by using this strain gauge. So, in different angle of orientation we are providing the strain gauge. By using these things we can easily be able to find out the direction and magnitude of the strain as well as residual stress in different direction. From there we can easily find out what is the principal residual stress and its direction as well as its magnitude also. Okay, that I will discuss in details here. So, first of all I am just symmetrically showing how this techniques is look like. So, here generally these three strain gauge we use. So, each strain gauge, generally the angle between two strain gauge is 120 degree. How it is I am just showing. So, let this is one strain gauge, let us strain gauge 1, and I am writing strain gauge 1. So, in between this 120 degree, here is a strain gauge 2, this is a strain gauge 2, and here generally another strain gauge is used, this is a strain gauge 3. This you should keep it in mind. So, the angle between here also it is 120 degree. So, this is the generally here at the center of this strain gauge location, there is generally make a drill hole. This is the drilled hole. So, once we make this hole inside this strain gauge, now from here to here, this drill hole center to this strain gauge location is generally called let us length. that the distance, or you can say you can write a d also. So, length between drill center to strain gauge location, okay, strain gauge location, this will be better, this is the distance, okay. Well, so here we know this 3 strain gauge location. So, what we know that once we make a hole here, so then around this hole, or you can say in hole location, if there will be any residual stress, due to this residual stress, generally we know the residual stress is due to elastic strain. So, if there will be any elastic strain, once we make a hole, the elastic strain will release. So, whatever the elastic strain will release, this elastic strain will be sensed by this strain gauge 1, 2 and 3. Okay, this strain gauge 1, 2 and 3. So, by using this strain gauge 1, 2 and 3, we can get we can acquire the data by using some data logging system. That strain generally we use to find out what it is called strain in different direction. That means what should be the strain in x direction, what should be the strain in y direction, and what should be the strain in z direction. Or the means especially x, y and here shear strain, because we are measuring the strain in 2-dimensional case. That is why here we will measure the strain in 2 direction. This is a plane stress condition, you can say. So, here we are generally measuring the strain in 2-dimensional way. One is horizontal axis, another one is vertical axis. But by using this 3 strain gauge, generally we can, why we are using 3 strain gauge, because to predict the principal strain, or you can say principal stress, residual stress, and in its direction, this 3 strain gauge is required, because in whatever the formulation we will use to calculate this strain, there is generally 3 unknowns are there. That is why what happens once we use 3 strain gauge. So, by using 3 strain gauge, 3 equation we will get, as they in that equation 3 unknowns are there. So, we can easily find out the strain value in different direction. So, how it is, that I will now show you. Okay. So, here you see, we know last lecture already I have already discussed, if a body is subjected to, let us epsilon x, epsilon y, different types of strain. So, what happens, let us, if we take any inclination of this body, any inclination of the body, then let the angle is theta. That means, if this will be theta, then you can say this will be also theta, correct, this also will be theta. So, along this direction, along this theta direction with that means theta which makes a angle with horizontal axis. So, along this theta direction, what should be the strain, that we can easily find out. It is well known to you, I am just directly writing that formulation. So, epsilon theta we can easily find out with the relationship of epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 cos 2 theta plus shear strain gamma xy by 2 sin 2 theta. Always keep this thing in mind, this angle generally with this epsilon theta is theta with horizontal axis, this you should keep it in mind. So, here you can see in this equation there are 3 unknown, this 1, 2 and this gamma xy. So, to find out this 3 unknown, that is why in previous slide I have shown 3 strain gauge we place. So, depending upon this theta value, and we can get 3 equation by using this equation number 1. So, from here we can easily find out what is epsilon x, what is epsilon y and what is gamma xy also. Now, last lecture I was discussed that okay, once a body subjected to plane stress condition, that means in a 2-dimensional case, last class I have already discussed, if we know that epsilon x, epsilon y, and if we know this shear strain, and if we know this Poisson's ratio, let us use the Poisson's ratio, and if we know this Young modulus E, Young's modulus E plus E, then we can easily find out what is the sigma x. So, in plane stress condition, last lecture I was already derived this thing, that means sigma x is equal to your E by 1 minus mu a square epsilon x plus mu into epsilon y. That means, here how we can find out this principal stress and its direction, that I am just going to show you, and sigma y equal to E by 1 minus mu square epsilon y plus mu into epsilon x. So, in last lecture I have already discussed about this thing. So, by using this strain gauge measurement data, we can also measure what is sigma x, what is sigma y, correct. So, once we know this sigma x and sigma y, we also can easily find out what is the stress value in any direction. That means, sigma theta relationship also known to us. That means, sigma theta will be your sigma x plus sigma y divided by 2 plus sigma x minus sigma y by 2 cos 2 theta plus shear stress tau x y sin 2 theta, correct. Let this is equation 2. So, this is the stress distribution at any angle of inclination. That means, let this is your sigma x, let this is your sigma y. Now, let we take a inclination angle. So, the normal stress sigma theta and its angle, let this is theta, this angle with horizontal axis is theta. So, sigma theta will be represented as like this. So, once we know this sigma theta, then we can easily find out what is the maximum stress in that body. What is this maximum stress? This relationship also is, this is the means solid mechanics concept, which is very well known to you. So, I am not going to derive this relationship because you see it is already well known to you, because you know Morse circle. So, from there generally or some analytical formulation and its derivation is there in solid mechanics. So, there from there you can get easily this relationship. Now, to find out this principal stress and its direction, what are the thing? Principal stress means maximum normal stress or minimum normal stress. Okay. So, maximum normal, for finding out maximum and minimum normal stress, what are the things we have to do? We have to do just del sigma theta by del theta and make it equal to 0. Okay. So, by equation 2, if we just do these things, we can get a relationship sigma x minus sigma y by 2. This cos 2 theta will be minus sin 2 theta into 2 and plus tau xy will be your cos 2 theta into 2, and this we are making equal to 0, because to find out the principal stress direction, that what I have told you, that okay, by using this what is called Measurement-2 drilling technique, we can find out the principal stress as well as principal stress direction. So, that is why by using this equation number 3, what should be the direction? So, here we can easily find out tan 2 theta will be this 2 theta will be your 2 tau xy divided by sigma x minus sigma y, correct. This is very simple derivation. So, by this we can easily find out what is the theta value. So, theta value will be your, you can say here I am writing theta p, that means theta principal. So, this we can easily find out, this will be your half of tan inverse, you can write 2 tau xy divided by sigma x minus sigma y. Okay. This we can easily find out. So, this is the direction of principal stress. So, this I am showing in equation number 4. So, what I told you, so once we can find out this epsilon f epsilon y, so we can easily find out what is the direction of principal, that means maximum or you can say minimum residual stress. So, always keep this thing in mind, difference between maximum and minimum stress is 90 degree, okay, that you should keep it in mind. So, once we know this theta p, then also we can easily find out what is the maximum and minimum principal stress, sigma 1 and 2 also we can easily find out, this will be your equal to your sigma x plus sigma y by 2 plus minus, then one time it will be plus for maximum and minus for minimum, sigma x minus sigma y by 2, okay, whole square plus tau xy whole square. So, this is very well known to you. So, by using once we can able to calculate this epsilon x and epsilon y by using this equation number 1 and by the measurement of the what it is called strain gauge, then what happens, by putting that value we can easily find out what is epsilon x, epsilon y. So, once we know this epsilon x, epsilon y, we know that if we know the materials what it is called Young modulus is and Poisson's ratio, by this is a material property of that material. So, what happened, by multiplying this material property, by applying that material property, and we know this relationship between sigma x and epsilon x, epsilon y and mu and E relation, which I have already shown here, you can see. Okay, here I have shown. So, sigma x and sigma y we can find out. Once we can find out the sigma x and sigma y, we can find out the sigma theta. So, from this sigma theta we can easily find out what is the principal stress direction. So, in that direction what should be the principal stress, that also we can find out. So, what is the maximum residual stress exist in the specimen, in that welded specimen, whatever the specimen it is, that we can easily find out by this relationship. Now, we will discuss another stress relaxation residual stress measurement technique, that is called Gunnard drilling technique. How it's look like? So, for this technique generally what are the different steps we used to follow, that I am going to show. In this technique generally we used to make four drilling hole actually. In this techniques we generally make 3 millimeter diameter drilling hole at a distance between one drilling hole center to opposite side drilling hole center is 9 mm. Okay, this you should keep it in mind. So, here you see, so from this center of this drill hole to center of this drill hole distance is 9 mm. So, in a specimen, this is our specimen where we are interested to find out the what it is called residual stress. So, for first of all we have to make 4 different drilling hole. These drilling hole have a diameter 3 mm, okay, and distance between opposite center of one drill hole to opposite drill hole is 9 mm. So, after making this drill hole, what are the things required to do? We have to make a groove. This groove we have to make by trepanning operation. So, the groove diameter, how it is, that I am going to show. Okay, that is the groove diameter, this groove, that means we know trepanning operation. So, the groove diameter is this around this hole, we have to make a groove. We have to make a groove. Here I am just going to show. So, this is the trepanning operation tool cutting portion. Okay. So, what we are doing? So, we are making a groove here. So, that means we are removing this inert portion, what I am telling, understand. So, diameter, external diameter of this trepaned part is how much? 16 millimeter. This you should keep it in mind. This trepanning operation generally is done, I mean sequentially. Sequentially means you can say just we have to first throughout the thickness, step by step we have to trepan that portion and makes the groove. What I am telling, understand. So, a groove from the measuring point, here measuring point, let us center of this 9 millimeter circle, or you can say 16 millimeter circle. That means here this center, this is called measuring point. This you keep it in mind, measuring point. Okay. So, how to measure the stress, that I am going to show you. Okay. So, first of all, a groove of 60 millimeter from the measuring point is then trepanned around the hole in steps. That means step by steps we have to make this trepan hole through the thickness. So, if we see the through thickness diagram, then how it's look like, I am just through thickness one here I am showing. Okay. Then it will be more clear to you. So, this is the thickness. So, through the thickness how the shape is look like, that I am going to show. this is the 3 millimeter hole. Okay. This is the center distance, this side also there will be a 3 millimeter hole, because 3 thickness side view if you check. So, this is also 3 millimeter hole. After that, this is the generally trip end section. So, this is the trip end section. So, we know from this center to center distance is 9 mm, and this external distance of this trip end one is 16 mm, and the whole of this 4 different drill hole is 3 millimeter dia, and this center line, or you can say this center is called measuring point. This you should keep it in mind. So, what are the things we did? So, first of all we make this 4 different hole. After that, okay, we just trepan this inert hole portion by using some trepanning operation. Trepanning operation generally is done by wire EDM, cutting tool is there. So, here generally this is a hollow cutting tool with a thickness. So, due to this thickness, generally it cut like this. Now, this trepan operation is done step by step. So, whatever the once we let us what happens 1 mm 1 mm depth we are trepaned through the thickness. After that, generally we measure the perpendicular distance between hole to hole. What I am telling under hole to hole, that means so that things only here I have written. So, diametrical distance between this hole at different level below the surface of the plate is measured by means of specially designed. So, this distance between one center of hole to another center of the another hole, that means distance from one hole to another hole, here we generally measure by using some specially designed mechanical gauge. So, here we are using some mechanical gauge, this you should keep it in mind. Here we are not using any strain gauge. Okay. Some mechanical gauge we can measure the distance between one hole to another hole. This distance we have to measure during a step cutting by using trepanning operation. So, for first step let us 2 millimeter depth we cut. After that, at 2 millimeter depth wise we have to measure the distance between what is called perpendicular distance between this hole to hole. Side by side we have to also measure the perpendicular distance between surface to depth at which we are measuring the what is called we are measuring the diametral distance between one hole to another hole. Okay, that things also here I have written. So, the perpendicular distance between the plate surface, that means top of the plate surface to depth where we are generally measuring this distance, that distance also we have to measure. That means the perpendicular distance between the plate surface and the gauge location at different level below the surface is also measured. So, what happens once we do this trepanning operation, then what happens due to this trepanning operation, the distance between this hole, the stress will be released. So, once this stress will be released, this diametral distance between one drilled hole to another drilled hole will be changed, correct. So, that change distance generally every time at different steps we measure. So, depending upon this different depth, whatever the distance between drilled hole we are measuring from there at different depth location, whatever the residual stress will be there, that we can easily measure. Okay, that there for that some formulation is there that you can easily be able to calculate. So, by using that things you can measure the residual stress. That is why by these techniques you can calculate the residual stress present in the interior of the specimen. This you should keep, that means through the thickness at different location what are the residual stress are there, that you can easily find out. This you should keep it in mind. Now, here one things you should keep it in mind, where is the application, what is the advantage or what is the drawback of this process, little bit here I am just telling. This Gunnard drilling techniques generally is a laboratory and field work types of techniques. The surface must be here substantially horizontal, because what happens we have to trepan this specimen, that is why position of this specimen should be horizontal in nature. okay, substantially horizontal, and so may be used for plate, cylinder or tube. These things we can use not only in plate, we can use these things in plate as well as cylinder as well as tube, but here actual use is limited due to its accuracy level little bit less, this you can say. Okay. So, its advantage is it is generally robust and simple apparatus, whatever, because you see here we only have to make some hole and we have to do some trepanning operation. So, that is why its apparatus is robust and simple. It's these types of techniques is a semi destructive types of technique, you can say. That means damage to the test object can be easily repaired, whatever the damage is occurring here, that we can easily repair. It has some disadvantage also. The disadvantage is because its error is little bit higher side, okay, in this Gunnard drilling technique. Now, I am going to show you another destructive types of, or you can say stress relaxation residual stress measurement techniques, that is called Rosenthal Norton sectioning techniques. This is a very interesting techniques. By these techniques we can measure the residual stress distribution in 3-dimensional way. How it is, that I am going to show. You see, this is a weld specimen, here I am showing in figure number 1. So, first of all, this technique generally is used for determining the residual stress in a thick weldment, you can say. Generally, once the weldment section is comparatively thick in nature, there this technique is more preferable, because here what are the things required to do? Here we have to make 2 narrow thin block. This is one block, this is a, you can say, rectangular shape I am just showing here, cross section. This is one block, this is another block, second block. So, this 2 block we have to generally cut. So, this 2 block, one parallel to the weld and another should be transverse to the weld. This generally are section with through the thickness, that means full thickness of this plate, you can see here. So, after removing this 2 block, this thin block, over the surface of this thin block we have to insert the strain gauge. That means in this block we have to once we cut it out, then what happens, at that times we have to put the strain gauge over the surface of the what is called this thin block. So, strain gauge are mounted on the wall of this block and strain relaxation is measured. After that, generally strain relaxation is measured, which is due to the result from the slicing of the block into small pieces. So, first of all we have to insert the strain gauge over that. After that, this this block we have to slice by slicing operation to make a small piece. So, once we slice it, at that times inside this block, if there will be any elastic types of strain, that will release, that means some expansion and contraction of phenomena will be taken place. Due to this, whatever the expansion contraction phenomena will be there, that we can easily record by this strain gauge, and we can what it is called by that strain gauge record we can easily predict the residual stresses. Here one thing you should keep it in mind, in previously in case of method weighted drilling techniques, whatever the formulation I have shown, that is generally stress strain, whatever the things we measured. So, here one thing keep it in mind. So, by using that formulation only we will measure the principal stress, then that means what is the maximum residual stress, minimum residual stress, as well as in that plate what is the stress in different direction, and through the thickness also we can measure the residual stress distribution depending upon the position of the strain gauge. This you should keep it in mind. So, here as we are using 2 block, so by using 2 block, one stress distribution we can get along horizontal direction, as well as due to another strain gauge in another section, there we can measure the residual stress in transverse direction. So, and also depending upon the position of this strain gauge through the thickness, we can measure the through thickness residual stress also. That is why here at the last point I have shown 2 block, one longitudinal and other transverse must be cut in order to determine the 3-dimensional stress distribution. What I am saying, that means longitudinal, transverse, and through the thickness also we can measure. So, this is called Rosenthal Norton sectioning techniques. Now, this Rosenthal Norton sectioning techniques is a destructive types of technique. It is because here it is a completely destructive types of techniques, and this technique generally is a time consuming types of technique, you can say. this is the one of the disadvantage you can say of these techniques, and its main advantage is fairly accurate data can be obtained. That means whatever the result it is provided, it gives fairly accurate data, and it's applicable generally for thick plate section, and it's a laboratory types of measurement. In last class already I have explained. That's why by using this strain gauge, whatever the stress you will get or strain you will get, with that we have to multiply a negative sign. That means opposite of that is actually there in your specimen. So whatever the strain gauge data you will get, so actually in a specimen it should be opposite of that data, because I have already explained. Because let's a specimen which is in tension, let's initial, so initial length was this much. So due to locked in elastic strain, let's is elongated like this is the final length LF, and initial length was let's L0. Now once we just release this strain, that means once we remove the support from here, if we remove this support from here, it will return back to its original shape, correct. So actually once it is locked in, at that time it was in tension, okay. But during this tension time we insert generally a strain gauge. So let this is our strain gauge, okay. This is the strain gauge we put, okay. The strain gauge we put here. So we know this due to this locked in, due to this two support or elongation, inside this specimen there will be tensile types of strain, correct. But once we just remove this support from here, this means elongated one will compress and it will return back to its original initial length, correct. Once it goes to its original length, then this strain gauge will compress. So generally strain gauge will record compressive types of strain, correct. But actually in this specimen when it was locked in, that was tensile in nature. That's why whatever the record we got from the strain gauge, in actual case there should be opposite of that. That's why what happens, we have to multiply by negative sign. This you should keep it in mind, okay. Now here I am going to show another residual stress measurement technique, that is called surge boring residual stress measurement technique. This is the symmetric diagram of the surge boring residual stress measurement techniques. Here I am just going to show how to measure the residual stress by using surge boring technique, that I am discussing here. So this is also a destructive types of techniques you can say. So first of all, here we have to prepare the sample. Here you see. So here for that means prepare the components sample. After that we have to make the surface of this sample very nicely polished, okay. So because what happens, we have to insert the strain gauge over the surface of this. You see these are the different strain gauge we have shown, different strain gauge in different direction. So here I have written already, this is the strain gauge. So we have to insert the strain gauge over the surface of this specimen. This, for inserting this strain gauge, this surface should be neat and clean. Always keep this thing in mind. There should not be any dust and other things, because dust or grease, that should not be there. If there will be any types of dust or other things, then what happen, your strain gauge reading will be wrong. That's why I have already told, whatever the strain gauge related measurement are there, that measurement or that strain gauge generally should insert in a laboratory types of room, because your surface should be neat, clean to insert this strain gauge, because this is a very sensitive types of component, okay. So once there will be a little bit dust or unclean types of portion over there, then what happen, your reading will be wrong. So after polishing the surface, first of all, what are the things we require to do? We have to glue the strain gauge to the component, and once we insert this strain gauge to the component with this strain gauge, there we have to insert the what it's called lead wire. So that means this lead wire means this strain gauge have two end, you know, the strain gauges look like this, a winding of thin wire. So it has two outlet. So these two outlet generally connected to some data logging system by this lead wire. Okay, this is wire. That's when data logging is done, or you can say this, whatever the expansion and contraction is there, this wire is connected to data logging system. There we can record the strain value. So after that, in this surge boring technique, what are the thing required to do? We have to make hole. Here you see, starting from a small hole to sequentially enlarging the hole. What I am telling, understand that you can say. So to make this hole, first of all we have to align, or you can say position this specimen in cutting machine, correct, in cutting machine, because this hole we have to make. You see, this is the hole, starting hole. So this hole, generally after that we have to make, or we can say we have to enlarge that hole, or you can say we have to bore out or turn down the component in a series of increment. That means you see, gradually we increase this hole diameter. That means you see, by a series of increment you can see. So in every sequence of increment, we have to measure the, or we have to record this strain by using this strain gauge with data logging system. Okay. So record the new diameter side by side. Also we have to record the strain gauge reading for each incremental layer removal. This you should keep it in mind. And finally, for different diameter, whatever the strain we are getting, we have to analyze this diameter and strain gauge data to calculate the residual stress distribution. Okay. So by this residual stress distribution over a distance itself, because we are starting from a small hole. So due to this small hole, in that location whatever the strain was there, that we are recording. So we are enlarging the diameter. So in different enlarging diameter, what are the stress or strain releasing, that strain at different location we can get. So here we can get the stress gradient over a wide range, we can say over a wide area. That is why at the end I have written the resolution of this residual stress measured, and hence the stress gradient also we are measure is dictated by number of incremental in the material removal. Okay. At the last I have done, that means here a stress gradient also we can measure. That means through the particular distance, over a particular distance, how the stress is varying. That means with distance, gradient means what? Gradient means variation of stress with distance. That also we can measure. This you should keep it in mind. If the strain gauge are on the outer diameter of the cylinder, then layer will be removed from the inner diameter outward. This you should keep it in mind. So once the strain gauge we placed outside of this specimen, then we have to, you see, we are generally what it is called increasing the diameter toward this strain gauge downward, that means outward direction. Now let us, we have a hollow types of workpiece. So inside the workpiece we insert the strain gauge. So then at that times we have to generally cut the or remove the material from outside surface, and it should go inside direction, correct. So at that time generally strain gauge we are putting inside that hollow specimen, correct. So that is why here you should keep it in mind. Surge boring techniques mean here generally we are bore out, or you can say turn down the component in a series of increment. Okay. So these techniques was developed for measuring the stress as well as stress gradient. This you should keep it in mind. Now I am going to show you another stress relaxation residual stress measurement techniques. This is called deep hole drilling techniques. In this deep hole drilling techniques, you see there are generally 4 different steps we followed. This is a step 1, you see, a step 2, a step 3 and a step 4. In step 1 generally you see, first of all, let this is the black color represent, this is the welding region. So first of all we have to make the sample like this. After that we have to insert these bushes, 2 bushes, top side and bottom side. So it start with attaching bushes on top and bottom surface of the target area of the weld plates. Okay. The purpose of attaching bushes is to use this as a reference to examine the change in diameter of the reference hole before and after the stress release. Okay. So these bush generally we use as a reference, you can say. So before stress release, what was the diameter was there, after stress release what was the diameter was there. So, a reference hole was generally, after that a reference hole was generally gun drill with a diameter of 3 millimeter through the thickness of this plate, you can see. So, this is a gun drill, here I have written already. After putting this bush through the thickness, we generally make a hole. Okay. So, after making this hole, we have to measure the diameter, you can say diameter through the hole at different location by using air probe. What I am telling, understand what is air probe? So, here also I am just giving you some idea about air probe. So, air probe is such a device, you can say it is a mechanical types of device, you can say. So, let us it is made up of generally some steel types of material. So, you see it look like this. It look like this. Now, through it is a hole, okay, through this air is generally pass, and this is generally called here one air gauge nozzle, and another one is here also this is called air gauge nozzle. Okay, this is called air gauge nozzle. This you should keep it in mind. So, this air gauge nozzle generally once the air is passed, then what happens, this air is passing through this channel and it is pass out from this air gauge nozzle. So, if there is any obstruction here, let us here there is some obstruction, then what happens, this air generally creates some pressure and it is back through. What I am telling under back the sense. So, what happens, whatever the air is coming out from this air gauge nozzle, this create a pressure on this surface wall. So, this create a back pressure. By recording this back pressure value, we can find out what is the diameter over there. So, this is called air probe, what I am telling, understand. So, it is a mechanical types of gauge which is used to measure the internal hole or some other application also it can have. So, this air probe generally we use here. So, air probe also sometimes called air plug gauge. It is generally made up of precision ground hardened steel body. It is a precision ground hardened steel body, you can say. Okay. So, once air is passed through the body, probe body to the nozzle, where a back pressure is produced by the surface of the workpiece. So, an air gauge read out sense the resulting back pressure and display the size of the workpiece. Okay, this you just should keep it in mind. So, in second step, so after making the hole with bush, we generally measure the diameter by using this air gauge. This air gauge generally measure the diameter in different of orientation. Like what happens by rotating this nozzle position at 0 degree, 45 degree, 90 degree. So, and different location we measure the diametral distance through the thickness of this plate, okay, through this drill hole. After that, we have to do the trepanning operation, that means we generally make a bore by using trepanning operation and we extract this specimen from there. So, after removing the specimen from there, so in third step we have to do some trepanning operation by especially designed tool and it is cut by using EDM electrode, that means it is a hollow cutting tool. So, by using this hollow cutting tool and EDM system, we can make this hole, that means bore hole, and we can remove the portion inside this welding zone, what I am telling, understand. So, we remove this inside zone with this hole by using this trepanning operation, which I am showing in step 3. So, in step 3, a cylindrical volume generally taking the reference hole as its axis was coaxially trepaned. Okay, that means whatever the initial axis was there, it's coaxially generally we trepaned that cylindrical volume, okay, which is generally trepaned out of the component using electro discharge machining operation, that means EDM operation. So, after removing this trepanning portion, from that trepanning portion also again we have to measure the what it is called, measure the diameter using air probe. So, before trepanning operation we are measuring the diameter, after trepanning operation also we measuring the diameter. So, once we do the trepanning operation, due to this whatever the stress was released, that stress release will provide the change of diameter of that hole. Okay. So, once we measure this again diameter of this hole, there will be change of diameter. From this change of diameter we will be able to measure the residual stress distribution. So, from this variation of dimension we can measure the strain. So, by measuring strain we can also measure the stress. Now, at different location, by positioning this wire probe at different location, at different distance residual stress distribution through the thickness we can measure by using these techniques. So, these are the different steps which I have explained here. Okay. Whatever the things I told, that means step 1 I have written how to make this thing, that means the purpose of attaching bush is to use this is as a reference to examine the change in diameter of the reference hole before and after the stress release. Okay. Then this at a particular position at different orientation we have to measure the dimension, that is 0 degree, 45 degree and 90 degree. So, similarly this 0 degree, 45 degree, 90 degree orientation by using air probe, after trepanning operation also we have to measure the dimension. Okay. And finally, we have to calculate the strain by difference of this diametral change. Okay, at different locations. So, by this we can measure the residual stress through the thickness. These are the following references I followed for making this residual stress measurement topics. In next lecture, I will discuss about the different types of residual stress measurement techniques by NDT approach, that means non-destructive technique. Okay. So, this all of today's lecture. Thank you.